Welcome back, mathematicians. In this video, we are going to do more examples with reference angles. And these problems are requiring us to evaluate the trigonometric functions using reference angles. So first, let's look at problem number 1, which is the cosine of 135 degrees. Now to do this, let's start by finding the reference angle for 135 degrees. I'm going to go ahead and draw a picture so I understand what I'm given and what I need to find. My terminal side for 135 degrees will be in quadrant number 2 with counterclockwise rotation. To find that reference angle, which is made up of the terminal side of angle theta, or 135 degrees, and the negative x-axis, I'm going to go ahead and take 180 degrees minus 135 degrees to give me a difference of 45 degrees. Now, because of the fact that the reference angles are going to change my trigonometric functions and evaluate them all at acute angles in quadrant number 1, and what we know is that every trigonometric function, when evaluated for an acute angle, will result in a positive ratio. But the original problem may not necessarily be positive. So that's a long-winded way of saying basically I need to then change the 135 degrees into 45 degrees, so cosine of 45 degrees. But in order to accommodate for the fact that my ratio may actually be negative, I'm going to put a plus or minus in front of that. Now I evaluate cosine of 45 degrees. Well, cosine of 45 degrees is going to be square root of 2 over 2. And then I identify whether my ratio should be positive or negative based on the quadrant that my terminal side lies for my original problem. So because my terminal side lies in quadrant number 2, and we know that cosine is negative in quadrant number 2, it means my answer should be negative square root of 2 over 2. So with these problems, I'm always going to start with a plus or minus of the trigonometric function with the reference angle, and then identify whether my answer, my ratio, should be positive or negative. Now let's go to tangent of 600 degrees. And what I notice right away is that 600 degrees is larger than 360 degrees. So I'm going to start by taking 600 degrees minus 360 degrees to find my coterminal angle, which is 240 degrees. So this tangent of 600 degrees is equal to tangent of 240 degrees. Now I'm going to evaluate tangent of 240 degrees. To do that, I'm going to use a reference angle. I know that my terminal side for 240 degrees will be in quadrant number 3. And then I need to identify my reference angle. My reference angle is going to be this angle here. So one more time, 240 degrees will be this rotation here, counterclockwise rotation. So in order to find that reference angle, I'm going to take 240 degrees minus pi, or 180 degrees, which gives me a difference of 60 degrees. This means that tangent of 240 degrees is equal to, again, don't forget the plus or minus, tangent of 60 degrees. I now need to evaluate tangent of 60 degrees, which is equal to square root of 3 over 1, or just square root of 3. And then I need to identify whether this should be a positive or negative ratio based on whether tangent is positive or negative in quadrant number 3. And what I know is that tangent is positive in quadrant number 3, giving us a final answer of just square root of 3. Let's now do two more examples. The first, where I have to evaluate sine of 17 pi over 6. What I notice is that 17 pi over 6 is larger than 2 pi, or one full rotation around the coordinate plane. So I'm going to start by finding the coterminal angle by subtracting 2 pi. I get a difference of 5 pi over 6. So what that tells me is that sine of 17 pi over 6 is equal to sine of 5 pi over 6. Now I need to evaluate sine of 5 pi over 6 using reference angles. Well, my terminal side of 5 pi over 6 will be in quadrant number 2 with counterclockwise rotation. That means my reference angle is made up of the terminal side of 5 pi over 6 and the negative x-axis. To find that reference angle, I'm going to go ahead and take the full angle, which is pi, and I'm going to subtract from it the part I don't want, which is the 5 pi over 6, leaving me a difference with, or of, pi over 6. I now can rewrite sine of 5 pi over 6 as plus or minus sine of pi over 6. So I am left with two things to do. First, I evaluate sine of pi over 6, and the second, determine whether the sine or whether the ratio of sine of pi over 6 should be positive or negative, given the fact that 5 pi over 6 is in quadrant number 2. So the sine of pi over 6 is equal to 1/2. Now I need to figure out whether that 1/2 should be positive or negative. Well, 5 pi over 6 has a terminal side in quadrant number 2, and sine of any angle in quadrant number 2 should be positive. So my final answer will be positive 1/2. Let's now go to the second example, where you're being asked to evaluate cosine of negative 2 pi over 3. So in this case, what you could do actually, if you prefer not to work with negative angles, is you could find the coterminal angle that is between 0 and 2 pi. You can do that by taking 2 pi minus 2 pi over 3. I'm going to go ahead and work with the negative 2 pi over 3, however, and because of the clockwise rotation, I know my terminal side is going to be in quadrant number 3. I now need to find the reference angle, and the reference angle will be made up of the terminal side of negative 2 pi over 3 and the negative x-axis. So ignoring rotation, what I'm going to do is take that whole angle, which is pi, and subtract from it the part I don't want, which is the 2 pi over 3, leaving me a difference of pi over 3. So what I know then is that cosine of negative 2 pi over 3 is equal to plus or minus the cosine of pi over 3. So now I'm going to evaluate cosine of pi over 3 and determine the sine based on the fact that the terminal side of negative 2 pi over 3 is in quadrant number 3. So let's start with evaluating cosine of pi over 3. What I know is that cosine of pi over 3 is equal to the square root of 3 over 2. Now I need to figure out the sine. Because of the fact that the terminal side is in quadrant number 3, and the cosine of any angle that's in quadrant number 3 is going to be a negative ratio, that means that my answer should be negative square root of 3 over 2. All right, guys, good luck.